Welcome back, everyone, and here we go with Chapter 6, your final chapter in the second session of RVA Earth Science. We are going to talk about the seasons. Now, this is going to take you back a little bit, especially to 5.5, where we talked about the Earth's motions. What we're going to look at is how the combination of the Earth's tilted axis and revolution around the sun causes the progression of seasons. Now, as we talked about before, the Earth is tilted, and it's always tilted in the same direction. The angle of the Earth's tilt doesn't vary over the course of the year at all. It's always 23.45 degrees. The northern axis points basically towards Polaris, the North Star, which is why we can always see it. Because of the tilt, the side facing the sun varies as we revolve around the sun. So as we move around the sun, the part that gets more sunlight is going to vary. The northern hemisphere is more towards the sun for half a year and more away from the sun for the other half, and vice versa for the southern hemisphere. That means the southern hemisphere gets exactly the opposite. So as you can see here, the Earth is revolving around the sun. Rotation is the Earth going around its axis. And a revolution is the Earth going around the sun. The tilt and revolution are responsible for the seasons. So as you can see, the sun is hitting more directly at the equator on the kind of top and bottom pictures, and on the left and right pictures, on the left it's hitting more on the top part of the globe, and on the picture furthest to the right it's hitting more on the bottom part of the globe. Watch the Earth as it revolves around the sun, and you can kind of see what's happening. Notice how the northern hemisphere is pointed more towards the sun when it's on the right, and more away from the sun when it's on the left. Sunlight. Sunlight is a portion of the electromagnetic radiation given off by the sun. That is what causes heat. It is scattered and filtered through our atmosphere, causing blue skies. It's visible as daylight when the sun is above the horizon. And that energy hits atoms and speeds them up. That's what causes heat. So there is direct and indirect sunlight. Direct sunlight is the sun is more directly overhead. The sunlight is more concentrated. The result is warmer temperatures and longer days. Indirect sunlight, the sun is less directly overhead. It's lower in the sky. Sunlight angle is more obtuse or diffused or spread out. The result is cooler temperatures and shorter days. The closer to the poles, to the North and South Pole, the more extreme you're going to see. So virtually no daylight in the winter, and virtually all day you'll have sun in the summer. So here's a good image of that. Look in the winter up in the north, and you will see that they basically get no sunlight at the North Pole. But down in the summer on the southern pole, they have daylight pretty much all day long, although it's very spread out. So it's not the warmest sunlight, but it's sunlight. Now, axial tilt is the reason for the season. The Earth's tilt is the reason we have changing seasons. So when the North Pole is pointed more towards the sun, it's summer in the northern hemisphere. When the South Pole is pointed more towards the sun, it's summer in the southern hemisphere. So here you can kind of see that. So when you have more direct light, it's warmer. You get more energy. When you have more indirect light, like we get in our winter, where we have sunlight, but it's much more, the sun is much lower in the sky, we don't get as much of the energy, and therefore it's colder, and we have snow and frozen lakes. So that is the end of our slideshow for the guide notes for 6.1. Hopefully you can explain how the combination of the Earth's tilted axis and revolution around the sun causes the progression of seasons. And just keep in mind, we live in Minnesota. We have 4 very different seasons. In the winter, the days are short. We have less sunlight. The sun is low in the sky, and it's cold. In the summer, the sun is higher in the sky. The days are longer, and the temperatures are warmer. So keep that in mind when you're thinking about how the seasons work, and compare that to the angle that the Earth is at compared to the sun.